Hello, everyone. If you can hear me okay, just give me a little comment in the sidebar here. I hope everyone's doing well. Looks like we have about 10 people on to start. So I'm just making sure that the audio is working okay. Can everybody hear me all right? Yeah, you can hear me? Is that good? Okay, so we do have, okay, sounds like the audio is good. Okay, perfect. That's great to hear. Thanks, everybody. So the lecture today is a little bit dense. We are talking about some concepts of data analysis. We're talking about a little bit of math. But what I've done is I've tried to kind of simplify it and stick to the core concepts as much as possible. I hope all of you are doing well, and if you have any questions along the way, just please add the comments to the sidebar or type in your questions, and I'll get to those questions as well. We can also save some time at the end of the lecture for questions about the final assignment, but one thing that I want to really make clear is the scope of the final assignment, so the written assignment, the scope of it is much smaller now. Previously, it was 3 countries. Now it's just 1 country and a maximum of 5 pages altogether. So that group assignment is 1 country, only 1 country analysis, and a maximum of 5 pages altogether. So we will save some time at the end to go through any questions about that as well, though. So for today's lecture, we're actually going through 2 chapters. We'll go through most of chapter 11 and then a little bit of chapter 12. My dog is asleep right behind here, so if you can hear my dog, I apologize. There we go. My dog wanted to say hi. So we'll get into chapter 11 now. So chapter 11 is data analysis, frequency distribution, hypothesis testing, cross-tabulation. So for what we've looked at so far, we've created these surveys, we've created these ways of getting content and gathering the data. Now we're going to analyze that information, right? All of these different observations, we're going to try to see if there are any patterns. We're going to look for some results. So the objectives in chapter 11, understand preliminary data analysis and why it's desirable, what insights you can obtain from such an analysis. We're going to talk about frequency counts. So one of the SPSS labs that we did was frequency analysis. And remember, we were just talking about how many times something occurs. So how many times in the survey that we did about Tommy Hilfiger in the brand recognition, how many people rate that as good or bad, or that scale of 1 to 6. So by frequency analysis, we're just talking about, how often something happens or how often something is observed. Number 3, describe general procedure for hypothesis testing. So remember that our hypothesis is kind of a best guess. When it comes to this type of analysis, we have our null hypothesis and our alternate hypothesis. So our null hypothesis is status quo. We think there is no change. We think there is no difference. And our alternate hypothesis is something that we're trying to statistically look at and test. So our alternate hypothesis might be that we think there is something going on. But we'll get into the details as we go there. Number 4, discuss how cross-tabulation analysis should be conducted. So we've also done a cross-tab in SPSS already, so we have some information to fall back on. And number 5, discuss other statistics used to test association between 2 variables. We're also going to do chapter 12, but a much, much condensed version of chapter 12. So we're only going to look at a few slides in chapter 12. Just to make sure that we focus on the key components. So if there are any questions, feel free to ask, but that's just the recap or the intro, I guess, as to the objectives for today. We've all seen this slide a bunch of times now. We're getting really close to the end, so we are on step number 5, preparing and analyzing data, and then the final step is just to prepare the final report. We've seen this as well, so we'll get right into the content now if everybody is good to go. I forgot to mention at the beginning, but the slides are on the course website. They are on the April 1st folder, and you can find the slides there. So you can follow along with those slides. Otherwise, it might be a little bit, you might be able to read the slides behind me, but it might be a little bit difficult to see all of the slides. So if you wanted to use the link on the course website, all of the slides are available there. So we're going to start with frequency distribution. This is a pretty simple way of analyzing data. You're just looking at how often something is happening. Question, why do we have the videos on Wednesdays and not Mondays? I just do the videos once a week, so you can review the videos anytime during the week. Just a way to get as many people involved as possible. So starting with frequency distribution, like I mentioned, this is a pretty simple analysis. We're just looking at how often these occurrences happen, right? So frequency distribution is one variable at a time and produces a table of counts or percentages for all of the values associated with that variable. So we've done frequency a few times. One of the times that we looked at frequency analysis in SPSS is we had that giant data set of 6,400 people. And that data set had their age and gender and marital status and income and all of those different things. And we created a frequency table or a histogram actually of all of the ages. So if you remember that, that lab that we did a few weeks back. So in that case, we were just counting how often each age occurs in that data set of 6,400 people. We had very few 18-year-olds and I think very few 80-year-olds, but everything else was just kind of in the middle. And the histogram had kind of a shape like this, where it went up and then down. So that's a pretty simple analysis. What we're looking at here is not only the visual representation in a histogram, but also a table. And that table had the counts of how often everything happened, the percentages as well. So of the larger data set, what percentage of this group was at the age 18, 19, 20, 21, and so on. So think back to that SPSS lab that we completed about frequency analysis. So how to conduct a frequency analysis? First, you're going to calculate the frequency and percentage for each value. You could do that manually. So count how often each observation occurs and then calculate that out. But we can use tools like SPSS and Excel to make our lives a little bit easier when it comes to that. Next, calculate the percentage and cumulative percentage for each value and adjust for any missing values. So we talked about what to do if you're missing a value in a data set. We talked about that last week. And here you're just going to calculate the percentages for each value as well. You can plot the frequency histogram. So that's just that bar chart that we created earlier. So you can kind of think of that as a path like that, right? Where we had a lot of observations in the middle for the age data and fewer on each end. Calculate the descriptive statistics, so measures of location and variability. By this, we'll get into some of the core concepts here of mean and mode and median. But by measures of location, we're primarily talking about averages, and variability, we're talking about how much variation occurs or exists in the data set. So are all of the numbers pretty much the same, or is there a huge variation between the different observations? One example that we looked at in class for variability, if you look at average heart rate, your heart rate throughout the day might be as low as 55 or so if you're just kind of resting, sitting down. And if you're going for a run or doing something strenuous, maybe your heart rate is up to 150 or 185. So that's a pretty big variation between those numbers. And if you, let's say you observe those numbers or you record those numbers once a minute for the full day, you'd see a pretty wide variation. If you took your temperature every minute throughout the day, regardless of whether you are running or sleeping or sitting down, your body temperature is going to be almost the exact same. There's going to be very little fluctuation, very little variability in those results. But we'll look at some specific examples of that as we go. So this was one of the tables that we used to plot frequency. This was the attitude toward Tommy Hilfiger, where the people filling out the form, they talked about their attitude towards the brand on a scale of 1 to 7. So 1 being they didn't like the brand, 7 being they really liked the brand. And we used this data set to run a frequency analysis. If you remember, this is what our frequency table looked like. So we had the possible values of 1 to 7, how often each one of those values happen. So number 6 was the most frequent. There were 9 observations of people rating the brand as a 6 out of 7, which accounted for 20% of the observations. So the lowest was 7. So only 4 people ranked the brand as 7 out of 7, which would be 8.9%. And we can move on from there. So percentage is just how often, or a percentage of the observations of the total group. Valid percent is a little bit different. So if you remember, we had one person that didn't give this an actual ranking. So one person didn't rate the brand. There was a missing value for that person. We labeled that as a number 9, just to showcase that this doesn't fall within that range, and we ignored that value when we were computing all of the averages. So looking at the valid percent, it's a little bit different than the overall percent. So the valid percent accounts for the one missing value in this case. So this was just looking back to our SPSS exercise about the frequency distribution toward the brand Tommy Hilfiger. And if you remember the histogram that we created, it looked something like this. This just plots visually the observations of the results. So this is just showing these values this many times. It's just showing that visually right here. Any questions about this so far? No, I think everybody's good. Okay. So next up, we'll talk about a real example of frequency distribution. So if we look at these 2 links on the slides, these are some examples from Stats Canada about the age of people in this country. So if we look at the population estimates, July 1st, 2016, we can see this table. So there's 2016, and it goes all the way to 2019. We can see this table of the different ages of people in Canada. So, or population estimates. So looking at, let's say 35 to 39-year-olds, it's saying that there's 1.2 million individuals who are between 35 and 39 in Canada. It seems a little bit low. Oh, sorry, this is just males, that's why. So if we go males and females, this makes a little bit more sense. So if we look at 2016, all the way up to 2019, actually, the 2016 estimate was 36 million Canadians. And now if we look at 35 to 39, there we go, 2.4 million Canadians who are between 35 and 39 years old. So this is a useful table, but it's quite difficult to read. There's a lot of content, and it's easy to get lost. So looking at a frequency analysis visually, this is a really useful way of looking at ages in Canada, for example. So we have, starting at 0, and age goes all the way up to 100 plus. The length of this line, on the right-hand side we have females, on the left-hand side we have males. The length of each one of these lines represents the observations or the number of people at that age. So let's go to 35 years old, and this was 2016 data, but in 2016, there were 468,360 Canadians who were exactly 35 years old. That breaks down to 229,640 males, 238,730 females, 1.33% of total males, 1.33% of total females. So the length of this line is males, the length of this line is females. This frequency analysis, or essentially it's just a histogram flipped on its side with two sets of data in there, both males and females. But this is a nice way to kind of represent a real example of frequency distribution. Any other questions so far? Looks like we're doing okay. So now that we're good with frequency, the next thing that we're going to talk about is measures of location, which sounds a little bit unusual when we're talking about data sets. What do you mean measures of location? For this first part, we're really just talking about averages or kind of the middle section of the data. So when we talk about average, the first thing that we think about typically is mean. So the mean is the average value. And that's the most commonly used measure of central tendency. So the mean, calculating the mean is just the number, the total sum of all the numbers divided by the number of observations, right? So you're adding everything up and then dividing it by the total number of observations. This notation, you might have seen it written this way, or there's other ways of writing that notation. But really, we're just talking about mean here. Add everything up, divide it by the number. Mode, we talked a little bit about already. Mode is just the value that occurs most frequently in a data set. So that's another way of kind of figuring out what the middle value is, or where things are kind of centrally located. Median is another example of a middle value. So the median is when you have everything sorted lowest to highest or highest to lowest. The median is just the middle value. If there is, if the number of observations are odd, then it's the middle value. If the number of observations are even, you just estimate it by averaging out those two middle values, right? So it's just the middle value in ascending or descending order. You can also think of it as the 50th percentile. Any questions about mean, median, mode so far? Okay. So now that we've talked about kind of finding the center point or the average or the middle of the data, and we've talked about frequency, how often things are happening, we're going to talk a little bit about the distribution of the data, so how things are sort of spread out. If we look at graphing this data, so let's use, we have, this is essentially a histogram flipped on its side. But if we use something a little bit more kind of simplified, this is a little bit tough to see. Bear with me 1 second here. There we go. So now we have we have two charts on top of each other of height data. So the blue graph is height data of males. The red graph is height data of females. And we can look at, if we look at them one at a time, this is what's called a symmetrical distribution. So it's almost like there's a mirrored line in between here, and not perfectly, but almost perfectly, both sides of each one of these distributions are a mirror image of each other. So what that's saying, if we look just at the male data height, so let's say just at the blue data height, the average height is about 176 centimeters or 5'9" approximately. and there are just as many people that are 168 centimeters as there are on the other side of that middle line. Not perfectly, but approximately. So that's an example of normal distribution or symmetrical distribution. Not all data sets look like that, though. So with symmetric or kind of normal, our mean, median, mode, they're all in the same line. So the observation that happens most frequently is also the mean or the average, and is the median, the middle value. Not everything is shaped that way. So a lot of data that we'll look at is skewed one way or the other. So if we look at this H pyramid, this is not symmetric, right? It's not kind of balanced. It's not a mirror image. There are all kinds of wavy lines that go through here. It's not symmetric. We can talk about skewed distribution. So if you can see this path, there's a long tail to the left and then a big peak right here, right? So a long tail to the left. In this case, the mean, median, and mode are not on the same line when it's graphed like that. So the shapes of these distribution, we have symmetric, so that's kind of the perfect mirror image. We have left skewed, where there's a tail on the left, right skewed, tail on the right. And occasionally we'll see a uniform distribution, which is just a straight line going across. It's not very common. Okay, any other questions so far? No? The next thing we'll talk about is measures of variability. So how much variation is there in the data set? Is everything almost the exact same, like body temperature observations, or do things vary quite a bit, like heart rate observations? The range is the first thing that we're going to talk about. So range is just the spread of the data, the minimum value, maximum value, the difference between those. So the range, we can calculate it really simply just by the largest value and subtract the smallest value from that largest value. Variance is a little bit more complicated to think about, but again, variance is just a measure of how much variability there is in that data set. So variance is the mean squared deviation from the mean and cannot ever be negative. So if we break that down a little bit, the mean squared deviation from the mean. The mean is the average of the entire data set, and the mean squared deviation from the mean, so the average of the difference between one observation, between that number and the mean of the entire data set. If it's a negative value and we square it, it becomes positive. So the variance is just the mean squared deviation from the mean for each one of those observations. Standard deviation is the square root of the variance. So standard deviation, again, is just a way of indicating how much variance or variability there is in a data set. Okay, so next we'll talk a little bit about general procedure for hypothesis testing. Previously, when we talked about hypothesis, we focused primarily on what we think the answer is going to be, or where we think the data set is going to move, or what observations we might find in a data set, what we think is going to happen, essentially. So when we talk about hypothesis testing, it's a little bit different here. So we have our first step. You can see it's written as formulate H0 and H1. That's the first step up here. H0 is just a way of noting that it is our null hypothesis. So what is the null hypothesis? The null hypothesis just means that we don't think there's any difference, right? We think that the two data sets that we're testing are the exact same, or we think that there is no measurable change that's going to happen. If we think back to the experiment that we looked at for the radio advertisements in the pharmacies, The null hypothesis in that case would be that radio ads do not change buyer behavior. The alternate hypothesis or alternative hypothesis is noted as H1 here. So that alternative hypothesis would be, we do think that the radio ads in the stores change the buyer's behavior or increase the number of purchases for the items that were advertised. So the null hypothesis is no change, status quo. The H1 or the alternate hypothesis is that there is there's something going on. There's something that we can observe. There's a question now, can you provide an example of variance? So variance, I would much rather be in the classroom to write this out on a big whiteboard to take everybody through this a little bit deeper. Variance, for the purpose of this course and for the purpose of this lecture, really for variance, what you need to focus in on or what you want to remember is it's a way of describing how much variability there is in a data set. So variance, it's difficult to explain in this video format, but here we're looking at, if you find the average of a whole data set. So we have our, if we go back to the attitude toward Tommy Hilfiger, if we look at the average value, we add up all of the attitude column and then divide it by the number of observations. So we have all of these different attitudes, we add them up, divide it by 45 because there are 45 observations, then that will give us our mean or our average value. Then if we, so we have our mean there, this mean right here. So the variance is the mean squared deviation from the mean. The mean squared deviation, here what we mean is looking at each one of these, if the average was something like 4.6, we would see the difference between the mean and each one of these values. Because there's a possibility that that is a negative value, we actually have to square it. So multiply it by itself. So that's the squared deviation from that mean for each observation. And the average, so the mean squared deviation, or the average of all of those deviations. That's a good idea as well. So explaining variance, can you provide a link to a video? Yes, I will provide additional information about variance that you can look up or you can review after this lecture as well. That's a good question. Like I said, I'd much rather be in the room with everybody to look at a deeper example of variance, but we're gonna do what we can here. So getting back to hypothesis testing, we've talked about our null hypothesis and our alternate hypothesis. So our null hypothesis noted as H0. Null hypothesis means status quo. We don't think there's going to be a difference. In the pharmacy example, the null hypothesis is those radio ads don't do anything. They don't increase buyer purchasing of those items. H1 is our alternate hypothesis, and H1 or our alternate hypothesis in the pharmacy case would be we think that there is a measurable difference between once we have the radio ads going. So we have step one, formulate our null hypothesis and our alternate hypothesis. Step two, select an appropriate test. Step three, choose a level of significance. Primarily for this course, that will be chosen for us. So we'll get to that in a second though. Step four, collect the data, calculate the statistic. Step five, determine probability associated with that test statistic, compare with the level of significance, and then reject or do not reject the null hypothesis. There's a lot of kind of double negatives and unusual language that we have in this structure of hypothesis testing. So remember again that our null hypothesis is we don't think there's a change. We don't think there's anything going on. The null hypothesis is status quo, things remain the same. We can reject or fail to reject the null hypothesis. So if there is something happening, so in the pharmacy example where the radio ads actually did increase the purchases of those items, we reject that null hypothesis. So we reject the idea that there's nothing happening. Again, the language is a little bit kind of difficult to wrap around, but what the outcome is that we're either going to reject or not reject the null hypothesis. We can't really say that we're going to accept the null hypothesis, but we can fail to reject the null hypothesis. And then we'll draw a conclusion based on that. So making sure that I said that properly, the null hypothesis would be that, in the pharmacy example, the null hypothesis would be that there is no change, but we reject that because there was a change. There we go. Okay, good. So we rejected the null hypothesis. So the general procedure for hypothesis testing, we talked a little bit about this already, but to go a little bit deeper into it, our null hypothesis is a statement of the status quo, one of no difference, no effect. If the null hypothesis is not rejected, then there are no changes. If the null hypothesis is not rejected, there are no changes. Again, the language is a little bit unusual. You can't typically say that you're going to accept the null hypothesis. That language doesn't work in this case. So a bit of a double negative. You're going to not reject the null hypothesis. An alternative hypothesis, one which some difference or effect is expected. Accepting the alternative hypothesis will lead to changes in opinions or actions. In this case, they write this, or the author of this textbook writes it as accepting the alternative hypothesis. Most of the time, you're going to not reject the null hypothesis rather than accept the alternative hypothesis. But we'll get there in a second. So the null hypothesis refers to a specified value of the population parameter and sample statistic, but you can primarily focus on the null hypothesis and alternative hypothesis. This table just shows the different symbols that we can use for variables both in the population and in the sample. So the population is the entire group, the sample is just the group that we are looking at, and the notation is a little bit different depending on if you're looking at population or sample. Okay, any other questions so far? Looks like things are okay. So general procedure for hypothesis step 1. Null hypothesis may be rejected, but you cannot accept a null hypothesis on a single test, not a single test anyways. Classical hypothesis testing, there's no way to determine whether it is actually true, which we talked a little bit about in the previous slides. So marketing research, null hypothesis is often formulated in a way that rejection leads to the acceptance of the desired conclusion. Again, I know the language in this is a little bit kind of tough to follow, but rejecting the null hypothesis is accepting the desired conclusion. I hope that that's clear. The alternative hypothesis represents the conclusion for which you're seeking evidence. Next, we're going to look at the test statistics. So that just measures how close the sample has come to the null hypothesis. We're not going to spend a lot of time here, actually, though. We are going to talk about type 1 and type 2 errors, though. So to set up the example of what type 1 and type 2 errors are, so type 1 and type 2 errors, they are, you have a test and you have what actually happened, trying to see that there are 4 possible outcomes of what actually happened. So this is our prediction on this side, and this is the observation of what actually happened. We don't know what actually happened until after the fact. Sometimes we don't ever know what actually happened. But in the prediction here, there are 4 potential things that can happen. I'm going to bring the camera a little bit closer just so we can see this for discussion purposes. So here we have the prediction was, yes, it's true. And the observation was, yes, it is actually true. So here we're good. True positive, we've hit it, it's successful. The other accurate part would be down here. So the prediction was no, the observation was no. So this is a true negative. Again, we're correct. We correctly identified this as negative. But what can happen is a type 1 error. So we predicted that it was yes, we predicted that it was true. The observation, though, said that it's actually false. So this would give us kind of a false alarm or false positive, and that's what we call a type 1 error. A type 2 error is that we predicted it was false, we predicted a no, but it actually was true. So we've got a false negative or a miss here, and that's a type 2 error. Another way to think about this is, we'll talk about our friend John here. So this is just a made-up person. So let's say John likes to go skydiving. He likes to jump out of an airplane with a parachute and float down. Not my kind of idea of fun, but some people love to go skydiving. So the null hypothesis, or the status quo, would be that the parachute is functioning properly. That's our null hypothesis. Status quo, no issues. We're assuming that the null hypothesis is parachute is functioning without a problem. A type 1 error, so that would be this one right here. Type 1 error would be that John thinks the parachute is not functioning properly, but in fact it is functioning properly. So he thinks that it's broken, but it is functioning properly. So because he thinks it's not functioning properly, he might not use it, he might not go skydiving that day. Type 2 error would be this one here, so false negative. Type 2 error, John thinks that the parachute is functioning properly, but in reality it's not functioning properly. So in that case, not good consequences. He would choose to use the parachute even though it's not properly functioning. So that would be the type 2 error. Type 1 error would be the false alarm where he thinks it's broken, but it's not. The type 2 error would be the false negative or the miss where he thinks it's working, but it's actually not working. Another way to look at this is the reality of what is observed up here. And down here is our test. I'm going to bring this a little bit closer again. So we have the reality of the first kind of upper left quadrant, the correct rejection of the null hypothesis. And then the bottom right is the correct acceptance of the null hypothesis or fail to reject the null hypothesis. The top right corner is the type 1 error. The bottom left corner is the type 2 error. So going a little bit deeper into these different types of errors, type 1 error occurs when the sample results lead to the rejection of the null hypothesis, even though it actually is true. And the probability of that happening is also called our level of significance. Type 2 error occurs when, based on the sample results, the null hypothesis is not rejected, even when it actually is false. So the probability of type 2 error is identified by that character there. Power of a test is the probability of rejecting the null hypothesis when it's false and should be rejected. So what we're talking about here is if we wanted to get really, really, really accurate and make sure that it's very unlikely that we would have any of these errors, we can do that, but it's going to be a ton of work and not very useful in practical terms. So we have to balance these types of errors. Okay, so we're making good progress. We're getting through it. Talking about hypothesis testing now, and as we move through, the next thing we're going to talk about are crosstabs. So we did a crosstab in SPSS. So we've kind of done the practical part of this, and now we'll review it and talk a little bit more about what it actually means. So if we go back to frequency distribution or frequency analysis, what we were talking about at the beginning of this lecture, there we're looking at kind of one variable at a time, whereas with crosstabs, you can look at two or more variables at the same time. So crosstabulation results in tables that reflect the joint distribution of two or more variables. So if we go back to the crosstab that we did in SPSS earlier on in the semester, we looked at people who made purchases of Tommy Hilfiger clothing. We have male and female, and then we've separated them into light users, medium users, and heavy users of that brand. This was based on the observations of the survey that was sent out to them. Here we have two variables. We have the amount that they use the brand and whether they are male or female. And the general rule here is to compute the percentages in the direction of the independent variable across the dependent variable. So I'll show you an example of this being correct. So you want to, again, compute the percentages in the direction of the independent variable. So across the bottom, everything adds up to 100%. So we have, for example, the male category. If we combine light users of male, medium users of male, heavy users of male, we get 100%. If we combine the light users of female, the medium users of female, and the heavy users of female, we also get 100% of those observations. The next slide that I'm going to show is an incorrect example. So you can see the incorrect in the background. Here this table computes it the wrong way. So looking at combining the male and female light users to 100%. The reason why this is incorrect is because this suggests that the usage of the brand determines gender, where that's absolutely not true. What is true, the gender determines usage of the brand in this case, or consumption of the brand, I guess you could say. Okay, so we've made it to the end of chapter number 11. If you do have any questions, I'll take a quick pause here to allow you to ask those questions. Otherwise, I'll move into chapter number 12, which is chapter 12 is hypothesis testing and a little bit of regression, but chapter 12 is very, very shortened. Can you please explain again? I don't understand. Which part would you like me to explain again? Was it the crosstabs? So for crosstabs, think back to the exercise that we did earlier in the semester. We were looking at whether or not we can find any patterns between how frequently somebody uses Tommy Hilfiger and their gender. So do males or females use that? So said last slide. So this slide right here is incorrect. Actually, I'll go back to the correct one first. So this slide is correct because the gender determines the usage of this brand. So here we're saying that males are more likely to be heavy users of the brand. Females are more likely to be light users of this brand. The brand usage doesn't determine whether somebody's male or female, but whether somebody's male or female determines how frequently they use this brand or how frequently they purchase from Tommy Hilfiger. This one is incorrect because it shows, or it's suggesting that the usage of the brand determines gender. I hope that cleared up the question. Okay, so we only have a few slides in chapter 12. Like I said, I condensed this one quite a bit. Okay, good, got it, thank you. The primary thing that we're going to talk about here is regression. So the objectives here, understand the role of t-distribution. We're not going to spend a lot of time on t-distribution. How to test the hypothesis in one sample, basic concepts of correlation and regression. So we will get to those. This is one of the last times we're going to see this slide. So we're getting close to the end. Hypothesis testing. Here we're talking about tests of association, but really we don't need to spend a lot of time here. I want to focus a little bit more on regression. So you can kind of flip through this slide here. So when we move to regression analysis, regression is a procedure for analyzing associated relationships between metric-dependent variable and one or more metric-independent variables. So here, if we think back to the scatter plot that we just did, we looked at the data that we were pulling in was the price of a vehicle, and we had a few different other variables. We had the horsepower, we had the size of the engine, we had the size of the gas tank, we had how the fuel economy of the car, and all of these other things that we were using to predict whether or not that other value, like horsepower, was a strong predictor of the selling price of the car. So with regression analysis, looking at a metric-dependent variable and one or more metric-independent variables. So the relationship there that we looked at was, or the one that we plotted anyways in the scatter plot, was price and horsepower. Bivariate regression is a procedure for deriving a mathematical equation in the form of an equation or a straight line between a single metric-dependent variable and a single metric-independent variable. So here we're just looking at one independent variable, one dependent variable. We can create a scatter plot, and that will give us kind of a scatter plot is a visual representation of regression in many ways, or that line that goes through the closest point of all of those observations is your regression line. And that's for one independent variable and one dependent variable. And then we'll look at multiple regression, a statistical technique that simultaneously develops a mathematical relationship between a single metric dependent variable and two or more metric independent variables. So here, it's unlikely, even in the selling price of the cars, for example, it's unlikely that only one of those variables explain the selling price. There are likely multiple things that explain the selling price. So we looked at horsepower as a good predictor, but that doesn't tell us the whole story. Another way you could think about this is the selling price of a house, for example. So if you think about, okay, what determines the selling price of a house, probably the size, so square footage, probably the location, the number of rooms, the number of bathrooms, the number of bedrooms, and you can keep adding on to that to give you a good predictor of the selling price of the house. So each one of those variables you can add together for our multiple regression. You're not going to need to remember any of these formulas, but you will need to remember the concepts. So the general kind of view of, one second. The general view of how all of this comes together, you can write it out mathematically, but it's a little bit easier to consume when we see it graphed as a straight line. So this is kind of how it's written mathematically. So A represents the intercept and B are the partial regression coefficients. So by the intercept, we just mean where it crosses, where the regression line, if it was graphed, where it crosses the axis. if we think back to the selling price of the vehicles, for example, it doesn't start at zero. The vehicles don't sell for $0. There's a minimum price that goes somewhere across that axis, right? So it crosses the axis at some point. Let's say the minimum price was $9,000 or something. That would be your intercept, so where it crosses the axis. Then the line kind of comes out from there, and the B's right here are the partial regression coefficients. So the horsepower is one area, the size of the vehicle, the fuel economy, and so on and so on and so on. Those will all, if you add them together, explain most of the reason of the selling price. Partial regression coefficient, the change in the predicted value of Y per unit change in X when the other independent variables are held constant. Bit of a long definition here. Practically what we mean here is if we think back to our data set of selling price of vehicles again, if you looked at, let's say, just looked at horsepower. So the partial regression coefficient there, if you increased horsepower by 1 unit, how much of a price increase would you see in the selling price? So let's say, I don't have the exact calculation in front of me, but let's say you raise the horsepower by 1, maybe that results in a $10 or $15 increase in price. So partial regression coefficient is just kind of that unit increase when all of the other independent variables are held constant. Strength of association, so coefficient of multiple determination is really just the strength of the association. So does it really represent the change? Not going to worry too much about this for the final exam. Just want you to be exposed to it. And then the adjusted R-square is for multiple regression. F-test, identifying the kind of the significance. But again, this is probably more than we need for this course. So we're not going to spend too much time here, and you're not going to need this for the final. And look at that, we are at the end of the slides. So the last question that just came through, how many chapters in the final exam? I will post some more information about that. So what you've already been tested on for the first half of the semester, that's not going to be on the final. So the final exam is everything from, I can't remember, I think it was chapter 6 all the way to 13, but very, very little of chapter 12. And because we also, in most sections of this class, we had to jump past the chapter on samples. The sampling is not going to be on there as well. So I will post a more in-depth kind of identification of what chapters you're going to need to focus on for the final. But the final exam is not cumulative, so you don't have to worry about those first few chapters that we've already covered for the midterm. Any other questions? I'll give everybody a second to ask any questions if they have any. Otherwise, I hope everybody's doing well. I would much rather be in class with you, but I think we're doing what we can with these live video chats. And of course, you can read and review these videos after the fact as well. The labs so far, I've been really impressed with the content coming in through the labs. So I hope those short YouTube videos are helpful in getting you to complete those labs. But so far, I've been quite happy with the quality of the labs coming in. Okay, so I think that looks like it's it. No other questions are coming through. But again, just wanted to remind everybody that for the final assignment, So the country profile. Initially, when we started the semester, the country profile was looking at 3 countries and a 10-page document. Now it's still done as a team, but it's only 1 country and maximum of 5 pages. So please stick to that format of 1 country and maximum of 5 pages. The value of the assignment is still the same number of marks, but the scope is much smaller now. Okay, so I think that's it. I don't see any other questions coming through. So thank you, everybody. Have a great week. And if you do have any questions throughout the week, either use the discussion board on the website or just send me an email. So take care.